Hey guys, it's 10 after, time to start up, I guess. Oh my gosh, it feels as though we learned a lot in a very short amount of time. And yet, for some of you, that's how it works best. I mean, I've had students in summer terms who have honestly said, "Oh, I think I learned it better because it was in this compressed time frame." Not everyone is one of those students, though. And I am going to, like I said, I've still yet to post that survey of, would you recommend this sort of an experience for someone else, or what else could I do to change things for you? Would you prefer in person, or if not, what are ways that, just questions that will help us at Cal Poly in the stat department figure out for future summer terms whether classes like this should be offered, or how could we change it to make it better and more popular. I'm not saying it's not popular. What I am saying is we want students to be able to take the class if that's what they want to do, and so to offer it in such a way that everyone can do it, we're good with. Okay, I guess that's not much for me, but I think going over administrative matters first would be good. What is, you should take the final. Two is, the final comes in two parts. Nominally named Exam 3, which is on relatively newish information. Think content that ties to stuff like the partial F test and since then. And then the final exam is more cumulative, emphasizing a bit more of the earlier content from the term. I'd be happy to answer administrative questions before we start up. Just to help you understand a couple things, though. Yeah, there's a bit of a mess with the labs. I think my ability to sort of set things up right in Canvas is suspect, because for those lab groups, I wanted it to be automagic and easy, like the grader fills in one score and like all four of you get the same score. So yeah, it didn't happen. So I have to go through and verify all of those. And so a couple of you sent me that email saying, "Oh, would you just?" Yes, we're going to get it done. Beyond that, though, any administrative issues that you want to raise? Any of you? Okay, how about subject matter questions? And there are sort of broad general questions that you might have, which is cool. And then maybe questions that are tied to something in particular. And I would want to go with content related to yesterday's discussion of logistic regression, and then questions from the sample exam. The sample exam questions are already in line, and yeah, so are the answers. Thank you, Kendall, for reminding me of that, because I hadn't put it up until earlier today. So any of you have broad general questions on statistics as a discipline, general themes like, hey, how do we estimate a thing? Or how do we test a thing? I'm going to declare that that was patience enough on my part to move towards more specific questions on logistic regression, the lab yesterday, or anything that came up in class yesterday. Any questions on logistic regression? Again, this is the last opportunity on logistic regression to really get a question addressed. Again, I'm going to declare myself having been patient enough to then say, okay, do any of you have questions on the sample exam in particular?
I do.
Yes. What is the question?
Okay, so for problem 4, part C, it was a partial F test. We didn't have the data, so I'm just wondering how would
Yeah,
you
okay.
calculate that number without having the data and running?
And yeah, good question. And this is an exam which was one that students did during a time period when, well, I guess they had access to the data differently. I'm not sure if it was on Canvas or a website or something, but they had access to, the data, happy final.html. That's a horrible name. But I tried to come up with a name that students couldn't pre-guess and look at the data in advance. So I think that worked okay. So on that sample final exam question 4, you say? Ooh, yes, I was being clever here. So at least, okay, so controlling for the area is at least one of the other variables related to the response. Yeah. Okay. The sequential sums of squares here for area would be helpful. That would be the, I guess, sums of squares for the model if that was the reduced model. The complete model has a sums of squares of, well, right up here, sum of squares for the model of 5.02022412. 4.8945641 is the reduced, I guess, no, that is the reduced model sum of squares for the model. And so the difference, or if you will, delta in sums of squares for the model equals delta for sums of squares error. So the change in sums of squares error or the change in sums of squares for the model is sufficient. And we're able to do this only because only because we have the sequential sums of squares here. So yeah, log 10 area, you know what the sums of squares for the model would be. Another way to tackle that is if the complete model is the one with all of these terms, and the reduced model is with just area, the sums of the sequential sums of squares, again, right here, there, and there, these 4 numbers added together, that would be the difference of SS error between the full and the complete model. Okay, so there you go. That is the way, or a way to get it. I happen to write this as 0.2415, yeah, as one of the reduced, the complete model sum of squared error. But that is not the only way to tackle it. And so the way I wrote it out, yes, it did suggest I had run an additional analysis. But if you take your SSE of 0.24, etc., and add to it these 1, 2, 3, 4 SS terms, sums of squares for these next 4 terms, that would give you the 0.4622414. So yes, probably running the analysis yourself, the reduced model is probably what most of you would choose to do, because that's done. That's easy. But yes, the sequential sums can be added up if you have them ordered, where the reduced model terms come first and the complete model terms are the later terms. You could use that trick I just showed you. So does that tackle your question, Kendall?
So for the reduced model, you would add the log area adjacent and the further ones to the original model sums of error?
Okay, so yeah, if we want to express things in terms of sum of squared error, the complete model's SSE, we get it right there.
Right.
However, if we take that 0.2415, etc., and add in this term first, and then this one, and then this one, and then yet again that guy, that would give you the sums of squares error for the reduced model with just log 10 area in it. Another approach could be you could take your sums of squares total Yeah. And subtract from it sums of squares for the model if the model was just with the log 10 area term. So, yes, it is a way, many ways of getting this difference in SS errors portion of our partial F test.
So is that supposed to give you the 0.462241, that number? Because I'm not getting.
So if we had 0.2415896 plus 0.0010991 plus 0.1011162 plus 0.0159798 plus 0.007 43600, I believe that is 0.4622414. It might not be. What?
It's 0.36726667.
Damn it. Okay. So could be a calculation error on my part, but yeah,
But
that would be
correct.
yes, that would be a way of doing it. It could be a typo on my part. Yes. And the typo isn't here inside JMP's output. The typo would be there.
Right. Okay. And then can you also go over part D?
B or D?
D.
Okay, going down a little bit. Okay, conceptually, would you have a higher maximum elevation of an island, therefore more species, controlling for other variables, like the distance to the next door island and the size of the next door island and etc.? My thought is if the island is taller, if you have parts of it sticking up into the clouds and other parts of it are quite low, you're going to have, and I'm just speaking conceptually here, some deserty sort of things. You're going to have some very coastal kind of things, and maybe even some temperate things, because every 1,000 feet you go up in elevation, it's a certain drop in air temperature. Different critters, different plant species live up there. So the number of species controlling for other things, I would expect to be more if you have a higher elevation. Everything else the same, but more tallness and more species. Okay, so controlling for all those other things, is there a positive association? And I've got elevation here with a slope of 0.196948. And the standard error is 0.077, et cetera. So that gives me a T ratio of 0.255, a two-way p-value, yeah. Two-tailed test for tackling the question, is there a relationship between elevation and number of species? Not, is there a positive relationship between elevation and species? So the p-value for our test, yes, is half of the p-value of this two-tailed test. Again, your one tail is half the p-value of the two-tailed hypothesis test. So I suspect that that's the reason why you asked the question, is the positive nature versus,
No,
hey, is there a relationship?
I understand that. I kind of did it wrong because I used the effects test. And because I took it as controlling for the other variables. So I was just wondering, like, why that's wrong.
Okay, so it's not completely wrong. So out of 5 points, that sounds like an answer which would be 3 out of 5 or 4 out of 5, just because you're doing something quite reasonable. In the effects test, you're saying controlling for all the other variables. Yes. Does this one have a relationship, whether positive or negative, with the response variable? In the parameter estimates, notice that our 1 degree of freedom terms, our F ratios are always the square of these t values, and the p values here are identical to the p values here. the effects test for 1 degree of freedom parameters or 1 degree of freedom model terms, it's always the same as the t-test values that you have in your parameter estimates. So you could, using your approach, you could say, because log 10 elevation has a positive slope, right? We know we want a one-tailed test. And so your p-value should be half of the two-tailed p-value. Because the effect is in the direction we suspect according to our alternative hypothesis, then the two-tailed or non-directional p-value cut in half should give you the p-value that you're interested in for the directional alternative of more height, more critters.
That makes sense. Thank you.
Yeah, so yeah, that's a great point to make. I haven't stressed this term, and our book doesn't stress really that these parameter estimate T ratios and the associated p-values are very much related to the F ratios in our adjusted sums of squares test. P-values being the same, it makes you think it's the same test. It really is. And if it's, again, 1 degree of freedom, so like not categorical variables with 3 or more levels, you can work from the T ratio to the F ratio just by squaring. Or if you had the F ratio, you could take a root of it, and with the sign here of your estimate, you know exactly whether it's the positive or the negative of the root. For example, 1.25 has a root of that 1.12. But because the log distance to Santa Cruz is a negative 0.07 negative, our T ratio would have a negative out front of it. Another question? Yeah, Alexandra.
Going back to part C, could you
Yes.
possibly show us how to get the p-value? Is that through the calculator?
Yeah, use the p-value calculator. Now, if you were working on this in a term when I hadn't given students that calculator to work from for the test, you could say, well, I don't know the exact p-value, but that's about 4, and 4 is quite a bit larger than 1. So I think we're likely to believe the alternative, but really we would need the p-value to get a solid conclusion. So you could, point towards what you think would be the case. And if you don't have time to use a p-value calculator and you want an exact p-value, it's probably better to write, well, our conclusion might be this because this F ratio is pretty large, quite a bit larger than 1.
Okay, yeah, that makes sense.
Yeah, it gets you to an answer, which is probably better than running out of time and getting no answer. Now, your hand is still up. Is that a vestigial hand or oh, there we go.
That's my bad.
Can you review one more time how do you get the 2 methods of getting the SSC for the reduced model?
Okay. We have up here, and maybe I'll make it bigger so I can read it more easily. Come on, maybe I can't do it, darn it. So I have my sums of squares error for the complete model. Yes, the model with all the terms. And this last sequential sums of squares is literally how much larger SS for the model is when we add in this last term than it was without this last term. In other words, our earlier SS error would be 0.0010991 larger if we had a model with only the first 4 variables in it. And so we know what SS error would be had the model been, well, everything but the adjusted, the adjusted island, adjacent island kilometer squared. What about elevation? Well, if we also peeled, in addition to the area of the next door island, if we also pulled elevation out, SS error would be, in addition to 0.00109991 larger, it would be an additional 0.1011621 higher. So yeah, literally the sum of these last sequential sums of squares would get you the difference in SS error between the two situations. So that's where Alexandra and Kendall both said, yeah, no, not that 0.461. And I think Kendall's answer was in the chat, 0.367 to 666, which is sort of close to what I think Kendall was mentioning earlier.
I think.
Yeah. So darn it. Oh, well. I'm glad you asked the question so I could clarify my error typo, if you will. Someone else? Or I shouldn't limit it to just someone else. Would any of the three of you so far who've had a question or someone else like to ask a question, whether it's an additional one or your first question? Okay, so while you're thinking that through, I'm going to make a couple recommendations. One, writing literally an 8.5 by 11 piece of paper, both sides, set of notes, a very limited set of notes, which is well organized, is super beneficial before taking a test, that's across multiple different topics. If you want to call it a cheat sheet, fine, go ahead and call it that. I didn't say you couldn't use it, so maybe it's not literally cheating. But across the different methods in their different contexts, and it's sort of hard to keep track of what are all the right methods to use to tackle one question or another. So you might very well want to have something like, okay, how do I check for whether the assumptions of the general linear model are met, or at least whether they're not unreasonable? So, your discussions will say the residuals check for normality with Shapiro-Wilk normal probability plot. You could also plot the residuals on the y-axis against one of your x's along the x-axis, or on the y-axis, and you got grouping information perhaps for categorical predictors along your x-axis. If you got a categorical predictors, you could use the Levine test to see if the spread of the residuals is larger for some categories than for others. And you could also look in a scatter plot of y or residuals along the y-axis and x's, or the predicted y's along the y-x-axis. You could look for a funnel-shaped behavior. Or frankly, one thing I did in class was I tried I tried finding the absolute value of the residuals. And if you plot the absolute value of the residuals on the y-axis and the x along the x, if you see a trend line that's upwards or a trend line that's downwards, and noticeably so, that says, yeah, there is a lack of equality of spread. So yeah, coming up with a cheat sheet that says, here are the list of those four methods to check whether the assumptions are legit, the chapter 8-9 content. And rather than listing as, chapter 8-9 content, it's more of a, hey, are the assumptions not unreasonable? Here's how to check. The only one we didn't really talk about so far was independence. And that is, at least according to our book, plotting the residuals against one of your X values and maybe doing it with an overlay for the different groups or different colors for the different groups. And you can see, oh, look, one group has a positive trend and the other has a negative trend. that suggests we needed an interaction. So narrow yourself down into like a bit of a scope. How many explanatory variables are there? Are they categorical or quantitative? And if they are categorical, how many different levels do they have? Two or three or more? And then what about the whole interaction thing? Yeah, so what else? Quantitative response, that's where we spent most of the term, except for yesterday when we talked about what if your response variable is, hey, you're in this group or that, you died or you survived. Not much different. We're still running a regression. We just now call it a logistic regression. But all of the content we learned sort of carries over. There are still tests of slopes. There are still effects tests. There are still, the test of slope is like controlling for the other x's. Does this x matter? So the bulk of what we've learned is applicable in this logistic regression or 1-0 response, success or failure response context. So yeah, a cheat sheet. Make one that makes sense for you, pass it to a friend, share it with them, say, hey, here's what I did. Excuse me, here's what I did. Does it make sense to you? Is it right? Is there something I'm missing? As you do that, working with a colleague, you're going to spot, your colleague spotted issues that maybe you would want to incorporate into your understanding of the material, a cheat sheet. Or maybe you're going to be helping them by correcting an error that they had made. Maybe it's only a conceptual error, but it's worth correcting. And so arguing over, now don't argue, discussing the positives and negatives of each of your cheat sheets, note cards, your summaries, is a great way of reviewing the material a little bit differently than just going over past questions. Someone else? Okay, well, here seems to be about the point in time where I'm going to say, I'm going to wait another 30 seconds before I stop sharing screen and say goodbye. But, you're welcome to hang out and ask questions. I'm here. I'm continuing to record, and I'll continue to do that unless one of you has a question you would like to ask, but not have it recorded. But that's for after I stop the recording, I guess. I guess what I need to do is count to 30 now, slowly. My cell phone has an old-fashioned clock on it with a second hand. So it's now sort of like going around past the 45 mark or the, I guess, 9 mark on the clock. Ten more seconds. Okay, that is, oh, go ahead, please.
Okay, for number 3, for I mean, obviously the x variables are continuous and the fx, the a's are categorical. So
Yep.
are you you're asking for an exact example, like saying like y is or like weight is equal to height kind of thing, like that? That's what you're looking for in that question? Or
Does weight depend on height?
yes.
Okay. Does weight depend on state that you're from, Colorado versus Texas? And that doesn't mean everyone in Colorado is skinnier than everyone in Texas, but on average, is there a difference between the two states? Well, there's a quantitative explanatory and a categorical predictor. Oh, the parallel lines model that we are looking at. X impacts Y via a slope, but there's different groups which allow us which allow our trend line to be different. And here's an example. Does Cal Poly GPA depend on high school GPA and or college that a student is enrolled in? Because we all know, actually, maybe we don't all know. Have you ever met engineers? And have you ever met folks who are business majors? Business majors for the same high school GPA have higher Cal Poly GPAs than the engineers who are lower. And then the other 4 colleges are somewhere in between. Yeah, I think maybe in engineering, they just grade harder. And in business, I won't say they grade easier, but maybe the students are smarter. Whatever you want to say, the GPAs are higher in some colleges than in others. So yes, there is a relationship between Cal Poly GPA Y and high school GPA X. And then in the different colleges, we are allowing for a difference in the intercept. Or shoot, hey, what if we've got our interaction as well that allows for the slopes to be different? That the GPA high school GPA relationship with Cal Poly GPA has a slope which is allowed to depend on the college that you're in. So for each 1/10 of a GPA increase in high school grades, maybe in engineering, it's going to have a 0.05 increase in your Cal Poly GPA. But in a business major, it might very well have a 0.2 increase in your Cal Poly GPA. Different slopes in the different groups. Okay, so does that get to your issue or question, Kendall?
Yes. Also for the transformations like log and square root and stuff, would you recommend reviewing like what specific criteria you would want for specific transformations, or is that not something?
No.
Okay.
So the reason I'm saying no is not that it's not important, but there are more important things. A, B, we haven't been focusing this term on how to pick the right transformation. The general question is one of, if I have y to the power phi, what is the best value for phi to achieve equality of spread, normality, and even linearity in the x transform y relationship? And so phi is some arbitrary power. Now, there are other transformations as well, but this is the most general set of ones that we consider. And there is an approach towards tackling the question, what is the best transformation? What is the best value for phi? It's in this area called these Box-Cox transformations. You may have bumped into that in looking at GMP. I've seen some Box-Cox transformation output. That's just a way of saying, hey, what's the best phi? And if the value of phi is 1 for y, you don't need to transform. If the value of phi is 2, you probably should square your y. If the value for phi is 1/2, you should take a square root. If the value for phi is -1, it should be 1 over your previous y, should be your new transformed y. And in a limiting sense, if we had a value of phi being 0, we're just going to say a log transform works really well. And I don't feel guilty about saying that. I'm just going to say there's a calculus-based argument for why WHY, the value y, your response variable to the power phi, as phi gets smaller and smaller and smaller, closer to 0, why it literally is a log transform. And if this had been one of those 10-week classes and you spent 23 hours between consecutive times that we were meeting, and in each class we had like, you doing something or me lecturing at you, and then but more response, we would have spent a little bit more time on those values feed. But it's on the back of one of our labs where it talks about, I guess the last page talks about transformations, when to use them and where. If your x variable Okay. If you have a lack of equality of spread and a lack of normality, typically transforming Y is the best approach. If you don't have a lack of equality of spread and don't have a lack of normality, typically transforming your X's would be one of the approaches that you should consider. But that's a typical. So I'm saying if you're a statistician, you could probably try it the one way and see if it works and try it another way. Eventually, it really boils down to straightening out a scatter plot and hoping that the residuals from a straightened scatter plot still follow a normal curve. And if they do, we're all good.
Thank you.
Yeah, the box cost transformation, that's more of a stat 323 or stat 324 context question.
Yeah, I kind of remember that when you said it.
Okay. I'm again waiting my 30 seconds. While I'm waiting, I'm just going to note that I have learned that maybe I shouldn't hum in class. Because one term when students were working on a quiz, I started humming. Now I'm off key and out of tune. But one of the students said afterwards, that was really distracting when you were whistling or humming during a quiz because you were humming If I Only Had a Brain. And I thought that was rude. I thought, oh, geez, I'm sorry. That was not my intent. It was because my daughters were in a kids play of The Wizard of Oz, and I just been listening to the music a lot as they were practicing. Anyway, If I Only Had a Brain might be something I would hum accidentally, so I learned to not hum. Okay, I've definitely waited that 30 seconds. So what I'm gonna do is stop the share and stop the recording, and we are going to call it a day. And you can